Today we will discuss about our topic magnetic field due to a solenoid carrying current. So first of all, what is solenoid? So solenoid is a cylindrical coil, this type of coil, cylindrical coil of many tightly bound turns of insulated wire, okay, and having its diameter smaller than its length. Its diameter is smaller than its length. This is L is the length of the solenoid. Now we have to calculate the magnetic field due to a solenoid carrying current. So for that we have considered this is a solenoid and solenoid, when the current is passing through this solenoid, then the magnetic field is developed across this coil. And this is the field direction of this magnetic this field is inside this magnet is from south pole to north pole, and outside the direction of the magnetic field is from north to south. Okay, so magnetic field is produced around this coil, means this solenoid behave like a magnet. Now we have to calculate the magnetic field intensity. So for that we have considered this coil, that the magnetic field around this coil is just like this. This is magnetic field and its direction is in upward, and this is the magnetic field, its direction is downward inside this bowl. Now we have to calculate the magnetic field intensity at point P. For that we have considered this rectangle ABCD. So this side of the rectangle, this path AB is well within the magnetic field, and these two sides, these two paths AD and BC, these two paths are perpendicular to the direction of the magnetic field. This is the direction of magnetic field, and side CD is outside the magnetic field. So total magnetic field due to this coil which we have placed within the this magnetic field. So for the total magnetic field, that is closed integral B dot dl across the loop ABCD is equal to integral A to B dot dl and integral B to C, then C to D and D to A. B dot dl, closed integral B dot dl is equal to total of the magnetic field due to this total sides A, B, B, C, C, D and D, A. Now this side BC and AD side are perpendicular to the magnetic. This is the direction of the magnetic field. This is the direction of magnetic field, and these two sides are perpendicular to the magnetic field, means the angle between B and DL here is 90 degree. So B to C B dot dl is equal to D to A B dot dl, means B dl cos of 90 degree, and cos 90 is equal to 0. Now path CD is outside the solenoid. So outside the solenoid there is no effect of magnetic field, means C to D B dot dl is equal to 0. Now magnetic field is only due to this path AB, because this path AB is well within the magnetic field, and here we will consider the point P where we have to calculate the magnetic field intensity. Therefore B dot dl, closed integral B dot dl is equal to A to B. It's not closed integral, this is integral A to B. Integral A to B B dot dl is equal to A to, here not, it's not a closed path, but B to A to B B dot dl is equal cos 0 degree B dot dl. Angle between this AB side and B magnetic field is 0 degree. So cos 0 is equal to 1. Therefore A to B B dot B D L, and closed integral B dl is equal to B into L. Integration of dl is here L because L is the length of the solenoid. Now we have to, according to Ampere circuital law, what is Ampere circuital law? That closed integral V dot dl is equal to mu naught time the net current enclosed by the loop, that is the circuit A, B, C, D. Therefore, B dot dl is equal to closed integral V dot dl is equal to mu naught. If n is the number of turn, I is the current flowing through the solenoid and having length L. Therefore, net current flowing in this is mu naught times n into I into L. Now, put this equation number 3. Now, comparing this equation number 2 and equation 3. So, B dot dl here VL and B dot dl here is mu naught n into L into I. Therefore, BL is equal to mu naught NIL. Now, L with L cancel, we get V is equal to mu naught NI. Here, if n is the, suppose this is the n is the number of turns, small n is the number of turns per unit length. Means capital N is the total number of turns. Therefore, this n small n is equal to n upon L, capital N upon L. Therefore, magnetic field B is equal to mu naught n upon L into I. So, this is a magnetic field due to a solenoid carrying current.